In this video, I am going to discuss about basics of machine learning. Machine learning, ML, is a field of artificial intelligence, AI, where computer systems learn from data to make predictions or decisions without being explicitly programmed. It involves using algorithms to find patterns in large datasets, enabling machines to adapt and improve their performance over time as they are exposed to more data. Machine learning models are the outcome of this process, used for tasks like classifying data, forecasting outcomes, and driving intelligent systems such as large language models.
What is machine learning?
Machine learning is a subfield of artificial intelligence where systems learn from data to identify patterns, make predictions, and improve performance without being explicitly programmed for every outcome. It uses algorithms to analyze large datasets, generating models that can make informed decisions, classify data, and perform complex tasks across various fields, from medicine to finance.
Machine learning definition.
The term machine learning was first coined in 1959 by computer scientist Arthur Samuel, who defined it as a computer's ability to learn without being explicitly programmed.
Core idea of machine learning.
Core idea of machine learning can be described with following key concepts.
Learning from data. Machine learning algorithms are fed large datasets to identify patterns and correlations within that data. Automatic improvement. The more data an ML model is exposed to, the better it becomes at its task. No explicit programming. The computer isn't told exactly how to do something, instead, it learns how to do it itself by finding patterns in the data. Making predictions and decisions. The outcome of this learning process is a model that can then be used to classify information or predict future outcomes based on new data. How it works.
Working procedure of machine learning can be described as shown below.
Data and algorithms. ML systems are fed large amounts of historical data. Algorithms are sets of rules and procedures that learn from this data.
Learning and pattern recognition. The algorithms analyze the data to find hidden patterns, trends, and relationships.
Model creation. The learning process results in a model, which is the trained output of the algorithm, capable of making predictions or categorizing new data.
Improvement. The more data the system is exposed to, the better the model becomes at making accurate predictions and performing its intended tasks.
Key aspects of machine learning. It can be described as shown below. Autonomous learning. Machines learn and adapt autonomously, requiring minimal human intervention after the initial setup.
Prediction and classification. A core function is to predict future outcomes or classify data into categories, e.g., identifying fraudulent transactions. Experience-based improvement. The system's performance gets better over time through exposure to more data, much like human learning. Examples and use cases. Machine learning is typically the most mainstream type of AI technology in use today. Some of the most common examples of machine learning that you may have interacted with in your day-to-day life include recommendation engines that suggest products, songs, or television shows to you, such as those found on Amazon, Spotify, or Netflix.
Speech recognition software that allows you to convert voice memos into text. A bank's fraud detection services automatically flag suspicious transactions.
Self-driving cars and driver assistance features, such as blind spot detection and automatic stopping, to improve overall vehicle safety.
Types of machine learning.
Mainly 4 types of machine learning methods to cater the need of the clients depending on their requirements. These 4 types can be described as
1. Supervised machine learning. 2. Unsupervised machine learning. 3. Semi-supervised machine learning. 4. Reinforcement learning.
Supervised machine learning. In supervised learning, algorithms are trained on labeled datasets that include tags describing each piece of data. Supervised learning is often used to create machine learning models used for prediction and classification purposes.
Unsupervised machine learning. Unsupervised learning uses unlabeled datasets to train algorithms.
In this process, the algorithm is fed data that doesn't include tags, which requires it to uncover patterns on its own without any outside guidance.
Unsupervised machine learning is often used by researchers and data scientists to identify patterns within large, unlabeled datasets quickly and efficiently.
Semi-supervised machine learning. Semi-supervised learning uses both unlabeled and labeled datasets to train algorithms. In this case, algorithms are first fed a small amount of labeled data to help direct their development and then fed large amount of unlabeled data to complete the model.
Semi-supervised learning is often employed to train algorithms for classification and prediction purposes when large volumes of labeled data are unavailable. Reinforcement learning. Reinforcement learning uses trial and error to train algorithms and create models. During the training process, algorithms operate in specific environments and then are provided with feedback following each outcome. Reinforcement learning is often used to create algorithms that must effectively make sequences of decisions or actions to achieve their aims, such as playing a game or summarizing an entire text. Benefit of machine learning. Key benefits can be discussed with relevant information for better understanding. Decreased operational costs. AI and machine learning may help businesses to automate some of its jobs, causing overall operational costs to decrease. Improved operational efficiency and accuracy. Machine learning models are able to perform certain narrow tasks with extreme efficiency and accuracy, ensuring that some tasks are completed to a high degree in a timely manner. Improved insights. Machine learning has the potential to quickly identify trends and patterns in large amounts of data that would be time-consuming for humans. These insights can equip businesses, researchers, and society as a whole with new knowledge that has the potential to help them achieve their overall goals. Risks of machine learning. Risks related to machine learning can be identified with description. Job layoffs. As some jobs are automated, workers in the impacted field will likely face layoffs that could force them to switch to a new career or risk long-term unemployment. Lack of human element. Models that are tasked with doing a very narrow task may also miss many of the human aspects of the job that are important to it but potentially overlooked by developers. Ingrained biases. Just like the humans that create them, machine learning models can exhibit bias due to the occasionally skewed datasets that they're trained on. Real-world applications of machine learning. I am going to discuss some of the important application in relation to machine learning. Detail information of each application given below. Image recognition. One of the most common uses of machine learning is image recognition. Data professionals train machine learning algorithms on datasets to produce models capable of recognizing and categorizing certain images and photographs. Some common applications that use machine learning for image recognition purposes include Instagram, Facebook, and TikTok. Translation. Translation is a natural fit for machine learning. The large amount of written material available in digital formats effectively amounts to a massive dataset that can be used to create machine learning models capable of translating texts from one language to another. Some popular applications of machine translation include Google Translate, Amazon Translate, and Microsoft Translator. Real-world applications of machine learning. Fraud detection. Financial institutions process millions of transactions daily. Perhaps unsurprisingly, it can be difficult for them to know which are legitimate and which are fraudulent. AI can help financial institutions detect potentially fraudulent transactions and save consumers from false charges by flagging those that seem suspicious or out of the ordinary. MasterCard, for example, uses AI to flag potential scams in real time and even predict some before they happen to protect consumers from theft in certain situations. Self-driving cars. Perhaps one of the more futuristic technological advancements in recent years has been the development of self-driving cars. While such a concept was once considered science fiction, today, there are several commercially available cars with semi-autonomous driving features, such as Tesla's Model S and BMW's X5. Manufacturers are hard at work to make fully autonomous cars a reality for commuters over the next decade. Real-world applications of machine learning. AI personal assistants. Everyone could use a bit of extra help. That's why many smart devices come equipped with AI personal assistants to assist users with common tasks like scheduling appointments, calling a contact, or taking notes. Whether people realize it or not, whenever they use Siri, Alexa, or Google Assistant to complete these kinds of tasks, they're taking advantage of machine learning-powered software. Chatbots. Effective communication is key for almost all businesses operating today. Whether they're helping customers troubleshoot problems or identifying the best products for their unique needs, many organizations rely on customer support to ensure that their clients get the help they need.
The cost of supporting a well-trained workforce of customer support specialists can make it difficult for many organizations to provide their customers with the resources they require. As a result, many customer support specialists may find their schedules inefficiently packed with customers who face a wide range of needs, from those that can be easily in a matter of minutes to those that require additional time. Future trends in machine learning. Future trends in machine learning include the increasing use of generative AI for content creation and autonomous agents, the development of explainable AI, XAI, for greater transparency, application of edge computing AI and automated machine learning, AutoML. Other key trends are the integration with quantum computing for enhanced speed, the creation of multimodal learning systems, and the ongoing importance of AI ethics and sustainability. I think you have got better understanding about machine learning, concepts, how it works, types of machine learning, benefits, risk, real-world application, future trends, etc. It helps to get better understanding about methods, tips, and steps in machine learning functions to cater the needs according to requirement of relevant task or field. If you like this video, please press subscribe button and many more educational and technical video you can see in the future. Thank you very much your attention.